Welcome to G Fun Facts Online, the show that uncovers the incredible science and stories hidden just beneath the surface of our world. When you think about military power, what comes to mind? Probably high-tech fighter jets, massive aircraft carriers, or elite soldiers operating behind enemy lines, right? It's the stuff of movies. But what if I told you that one of the most powerful tools in any modern military isn't a weapon at all? It's a bulldozer. It's a roll of blueprints. It's the incredible ingenuity of a group of people who are often completely invisible in these stories, the Expeditionary Engineer. Today, we're pulling back the curtain on their unseen saga. We're going to explore how they build and sustain entire cities from scratch in some of the most dangerous and desolate places on Earth. This isn't just about pouring concrete and putting up tents. This is a story of dust, determination, and futuristic technology that is fundamentally changing how nations project power across the globe. So buckle up, because we're about to build a base on the edge of the world. First, we have to ask, why the huge push for these new kinds of bases? In the old days, you might picture a giant, permanent military base, like the ones in Germany or Japan, that have been there for decades. They're like little slices of America plopped down in another country. But the world has changed. Modern conflicts and crises aren't always big, state-on-state wars. They're often fast-moving, unpredictable, and involve anything from counter-terrorism operations to delivering humanitarian aid after a natural disaster. You can't just build a massive, permanent city for every single one of those missions. You need to be fast. You need to be agile. The U.S. Army has a concept called expeditionary maneuver. That's a fancy way of saying they need to be able to show up anywhere in the world, quickly set up shop, and get to work. And that setting up shop part? That's entirely on the shoulders of the engineers. They have to create the literal foundation for everything else to happen. Without a runway, planes can't land. Without clean water and power, troops can't operate. Without a secure perimeter, everyone is a target. So, the ability to rapidly build a functional, secure base in a forward location isn't just helpful. It's the absolute cornerstone of modern strategy. It's what gives forces the platform to do their job, whatever that job might be. Okay, so we know why it's important. But let's talk about how mind-bogglingly difficult this actually is. Imagine your next big home improvement project. Now imagine doing it in the middle of a scorching desert, thousands of miles from the nearest hardware store, where the temperature can melt your tools. And you might have to do it all while under the threat of attack. That's the daily reality for an expeditionary engineer. First, there's what military planners call the tyranny of distance. Getting everything you need, from massive bulldozers and cranes to nuts, bolts, and bags of concrete, to a remote location is a logistical nightmare. Often there are no deep water ports for ships or long runways for giant cargo planes. So you're shipping things to the nearest possible point and then trucking it for hundreds of miles over rough, unimproved roads. The cost is astronomical, and the timeline is always at risk. A single delayed shipment can halt an entire project. Then there's the environment itself. We're talking about the most inhospitable places on the planet. Scorching deserts that can hit 120 degrees Fahrenheit, dense, humid jungles, where equipment rusts and corrodes almost overnight, or freezing, mountainous terrain. These conditions don't just wear down the people, they destroy the machines. And on top of all that, these engineers aren't just building an office park, they're building a fortress. Security is built into the design from day one, because in many of these regions, the construction site itself is a potential target. But perhaps the biggest challenge is that they start with nothing. Absolutely nothing. They need to create a fully self-sufficient installation. That means generating their own power, finding and purifying their own water, building their own communication networks, and managing all of their own waste. They are literally building a modern city from dust on the edge of the world. Faced with these incredible challenges, you can't just use old-school construction methods. You have to innovate. And this is where things get really cool, moving from a construction story to a science fiction story. Expeditionary engineering is in the middle of a technological revolution. Let's start with one of the most exciting developments: 3D printing. And I am not talking about those little desktop printers that make plastic toys. I am talking about massive, gantry-style printers that can extrude concrete and other materials to print entire buildings, layer by layer. Think about what this does. Instead of shipping thousands of tons of concrete blocks or prefabricated walls across an ocean, you ship a printer and use locally sourced materials like sand and gravel as your ink. This has the potential to slash costs, construction time, and most importantly, the massive logistical tail that makes these operations so difficult and vulnerable. They've already successfully printed barracks, walls, and other structures, and the technology is only getting better. Then there's modular construction. This is like building with giant, high-tech Legos. Entire rooms or sections of a building are pre-built in a factory, complete with wiring and plumbing, then shipped to the site and simply craned into place. This dramatically reduces the amount of on-site work needed, meaning you can stand up a fully functional facility in a fraction of the time. It also makes the bases more flexible. Need to add a new clinic? Just ship in a few more modules and plug them in. Finally, they're even rethinking the materials themselves. Instead of just steel and concrete, they're using things like mass timber. This is engineered wood, like cross-laminated timber, or CLT, which is incredibly strong, lighter than steel, and far more sustainable. It reduces the carbon footprint of the project and can often be sourced closer to the construction site. Now, you might hear sustainability and green technology and not immediately think of the military. But in expeditionary engineering, sustainability isn't about buzzwords. It's a hardcore strategic advantage. Every gallon of fuel or water that has to be trucked into a remote base is a weak point. It's a supply convoy that can be attacked, a resource that can be cut off. By making bases more self-sufficient, you make them more resilient and more secure. This is why you're seeing a huge push for renewable energy. Rows and rows of solar panels are being installed in desert bases. Wind turbines are popping up in windy corridors. These are often integrated into microgrids, smart, localized power grids that can operate independently. One NATO report found that using solar power systems can cut the use of diesel generators by over 30%. That's 30% fewer fuel trucks on dangerous roads. The same goes for water. In arid regions, water is life. Advanced reverse osmosis units and other purification systems can turn non-potable local water, or even seawater, into a sustainable source of clean drinking water, again, reducing the need for vulnerable supply convoys. They are even developing waste-to-energy systems, which can take garbage and turn it into usable power. This solves two problems at once. It gets rid of waste, reducing the environmental and health impact, and it generates more energy on site. Sustainability for an expeditionary engineer equals survivability. To see how all of this comes together in the real world, let's take a trip to a tiny country in the Horn of Africa called Djibouti. It's home to Camp Lemonnier, one of the most critical overseas U.S. military bases, and a perfect example of modern expeditionary engineering in action. What started as a small temporary outpost has been transformed into an enduring, long-term hub for operations across Africa, home to over 5,000 people. The U.S. has invested over $1.2 billion in this transformation. They've had to build new aircraft hangars, a new air operations center, expand the power plant, install new fire suppression systems, and upgrade everything from sewer lines to street lighting. But it wasn't easy. One of the biggest problems they ran into sounds almost mundane, but it was crippling. The maps were wrong. The original plans and records of where all the underground utilities were, the power lines, the water pipes, the communication cables, were inaccurate or non-existent. This meant that every time they went to dig, They risked hitting a critical line, causing power outages, water main breaks, and massive delays. To solve this, they had to launch a massive project just to figure out what was already there. A team came in and meticulously mapped every single pipe, cable, and conduit, creating a comprehensive digital map, a Geographic Information System or GIS database. This as-built record is now the lifeblood of the base's master plan, preventing costly errors and allowing them to plan future construction effectively. It's a powerful lesson. Sometimes the most advanced tool an engineer has is an accurate map. The work at Camp Lemonnier even extends beyond the base's walls. U.S. military engineers have partnered with the University of Djibouti, sharing knowledge and expertise with local students and faculty. This builds relationships and helps develop the local talent that will be essential for building infrastructure across the entire region. So, from 3D printing barracks in the desert to creating digital maps of a sprawling base in Africa, the world of the expeditionary engineer is one of constant problem-solving and innovation. They are the ones who turn a patch of barren dirt into a platform for global reach. As we look to the future, their job is only going to get more complex. Future conflicts may require bases that are not just rapidly deployable, but also stealthy and harder to detect. Engineers are already working on advanced camouflage systems and designing smaller, more dispersed bases that are less of a target. The saga of expeditionary engineering is a story that's constantly being written, chapter by chapter, in the most challenging environments on Earth. These unseen heroes, armed with blueprints and bulldozers, are the true architects of global security, laying the very foundations that allow for everything else to happen. Their work might be far from the headlines, but without it, the modern military couldn't function. And that is a G Fun Fact. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another incredible hidden story from our amazing world.